Hey guys, this is Mrs. Harbin, and this is our Algebra 2 presentation for Section 1.3, Simplifying Algebraic Expressions. Our life application is this. The student will develop accurate algebraic skills that will be the foundation for his or her math success. Just like you have to develop academic or skills in other areas as a foundation, math is no different. We want to make sure the foundation is firm before we build anything on top of it. Your lesson objective is that you, the student, will classify polynomials by their number of terms and degree, add and subtract polynomials, and apply definitions and properties to simplify expressions. Now, you should be familiar with these properties of exponents already. If not, I'm giving you a handout to put in the resources section of your binder. But these properties of exponents tell us how we can combine exponents when we're multiplying or dividing bases, same bases with different powers, identical bases with different powers. So you should be familiar with these. If you have questions, be sure to ask me. Let's talk about some definitions here. A term is generally considered to be simplified when each base appears only once, all fractions have been reduced, and there are no parentheses or negative exponents. That's when we know it has been simplified. So three separate things. Let's go ahead and simplify this expression. We have 4x squared times y. Actually, all of this is multiplication. If you look, we have 4 times x squared times y times negative 3 times x to the negative 2 times y to the negative 4. We've got two x bases and one y base, and we can combine these using our laws of exponents. Okay, our 4 and our 3, our two coefficients, are going to be multiplied here. And we can take our x2 and x to the negative 2 and rewrite that as 2 plus negative 2. And our y to the 1, remember the 1 is implied, and the y to the negative 4, and rewrite our y base that way using our laws of exponents. That simplifies to negative 12, x to the 0, y to the negative 3rd. X to the 0 is just 1. Anything to the 0 power is 1. And we don't want a negative exponent. The way that we get rid of a negative exponent is stick it down here in the bottom of a fraction, 1 over y to the 3rd. Combine all of that together and we get negative 12 over y to the 3rd. So let's use some properties to simplify this expression. We can simplify our terms. Whenever you have a base and exponent being divided by an identical base and exponent, you can just subtract the exponents, which is what we see here. S1 minus S3 and T7 minus T5 simplifies to r to the 5th, s to the negative 2nd, and t squared. Now, we can't stop there because we don't want to have a negative exponent. Remember what we can do to get rid of a negative exponent? Stick it on the bottom of the fraction. So we have r to the 5th, t squared, and our s squared that was negative is now down here in the denominator, so it is no longer negative. See if you can simplify this on your own using properties of exponents in your handout for reference. Okay, that square term is going to apply to both the numerator and the denominator. And then we can distribute that square term into everything that's inside the parentheses here. So we're going to rewrite that the way that you see below. Using our properties of exponents, this simplifies to 4a squared c8 over 25b to the 6th. We have no other bases that are similar. Nothing else can be simplified. Pause the video, try this one on your own, and then start it back up to see if you got it right. First thing we're going to do is distribute these exponents that are outside the parentheses to everything inside the parentheses. And when we combine our like terms and simplify, we get 27 over 4, x to the 6n minus 6, y to the 6 times y to the 6 plus 4m. And we cannot simplify it beyond that point, since we cannot combine these anyway because they have variables. Let's talk about types of polynomials. A monomial is a single term expression containing a constant, a variable with a whole number exponent, or the product of a constant and one or more such variables. Monomial, mono just means one, so it's a single or one-term expression. It contains a constant. A constant is a number, so that is a monomial. A variable with a whole number exponent, so a variable with a whole number exponent, that's considered a monomial. Or the product. Product means multiplication, remember, the product of a constant and one or more such variables. So, the product of a constant and one or more such variables. This is also a term. And those are all examples of monomials. The numerical factor in this type of monomial is called the coefficient. Coefficient. A binomial is a polynomial with exactly two terms. You know that bi means two, like in the words bicycle or binary. Bi means two. A trinomial is a polynomial with exactly three terms, and you know tri means three with your experience of triangle and tricycle. So here are some examples of monomials, binomials, trinomials, and then every other kind of polynomial. Now remember, all of these are polynomials. They're special kinds of polynomials because they just have one, two, or three. A polynomial is an algebraic expression with one or more monomials. We just have special terms for 2 and 3. The degree of a monomial is the sum of the exponents of its variables. So let's determine the degree. This is x to the first and y to the first, and the sum of the exponents there is 2. So the degree of that monomial is 2. What about letter B? What's the degree of that monomial? If you said 3 plus 1 plus 2 equals 6, then you are correct. Don't forget, if you have a variable with no exponent, it is implied or understood that the exponent is 1. The degree of a polynomial is equal to the degree of its highest degree term. So we're going to determine the degree of each term, and the degree of the polynomial is the one that is the highest. See if you can find the degree of each term. Pause, figure that out, and then come back. 4x cubed y has a degree of 4. 7x squared y cubed has a degree of 5. And 15y to the fourth has a degree of 4. The highest term there is that 5. So the degree of our polynomial is 5. Like terms are terms that contain the same variables with the same exponents. Now, I've seen students in the past try to combine terms like this, 3x squared plus 4x. These are not like terms. Even though they have the same variable, x, their x's do not have the same exponents. So these cannot be combined. However, 3x squared and 4x squared can be combined because they have the same variable and each variable is being raised to the second power. They have the same exponents. Let's try to simplify these. Now here we're not multiplying or dividing any exponents at all. So we're not going to use the rule of exponents. We're just going to combine like terms. I have an x squared and an x squared. I have an x and an x, and then I have a constant. So we're going to combine our two x squared terms, our two x terms, and our two constants. We can group those in the order that we want to combine them, if that's helpful to you, although you don't have to do this step. And then let's combine. Positive 3x plus positive 5x squared is 8x squared. Positive 2x and negative 3x is negative x. And negative 8 and positive 9 is positive 1. Be very careful that you're watching your signs. Now we're going to simplify this in just a second, but pay special attention to this negative sign. When you have a negative sign, it's really like a negative 1 being multiplied by that. Because it's a negative 1, that is going to affect the signs of everything inside these parentheses. So we need to be careful to distribute that negative sign to each of those numbers. We're going to rewrite it this way after distributing. and then look for some like terms. Now these are not color-coded, so let's see what we have. I have a to the third b, a to the third b. I have a squared b, and I don't have another a squared b. I have ab cubed and ab cubed, so I can combine those. And then I have ab squared, and I don't have anything else like that one, so that's not going to be able to be combined. Combining what I can, I end up with this simplified expression. Alright guys, today we classified polynomials by the number of terms and the degree. Remember the degree of a monomial. For the degree of a monomial, you just add up the exponents. For the degree of a polynomial, the polynomial takes the degree of the highest monomial, the highest part within it. A term can be made up of a constant, a variable with an exponent, or a combination of these two being multiplied, the product of a constant and a variable. We call that, when we're multiplying that, the coefficient. We also added and subtracted polynomials by combining like terms. Remember, in order for something to be considered a like term, it has to have the same variable being raised to the same exponent. So we cannot combine x squared and x. They're the same variable, but not the same exponent. We cannot do that. We can combine x squared and x squared. In fact, 1x squared plus 1x squared equals 2x squareds. We also applied the definitions and properties to simplify expressions. If you guys have any questions, be sure to ask.